welcome back. Ooh, does this work? That's a bit too high. Welcome back, everybody. Nice to see you here again after the lunch. Quite a few are still around. It's quite a good party. That's good. You're strong divers. Now we're going to have a discussion, open discussion about rebreathers. We have a lot of very knowledgeable people here, and I know that in the audience there's a lot of knowledgeable people too. So I think we're going to learn lots of interesting things about this. It's going to work like this. Then we'll introduce each other. Then I will start with a little question to them, and after that, the field is open for you to ask questions to the panel, either directly to one of the persons or to the panel as such, and we'll see who can answer. So don't be shy about the questions, but keep it to rebreathers, right? Nothing else. That's what we're talking about right now. Okay? So we start from here. If you please just introduce yourself.
I was introduced yesterday, but I'm Oscar Framberg, and in terms of rebreathers, I've been working together with the Swedish Navy and their procurement of a new rebreather, and I'm also participating in the European Standardization Committee, so basically write the tests and
Do you dive a rebreather yourself?
Well, I've used to be a clearance diver, so the Navy rig, but apart from that, it's usually OC.
Okay, thank you.
Hello, Lars Gustafsson. I'm currently working for Interspiro, a company that makes, apart from other things, but also respiratory protection equipment for firefighters and also divers professionally. We are supplying local navies around the world, and currently we are doing large work for the new rebreather for the Swedish Navy, which is of course interesting for us. I have a background and I'm still an avid sports diver, and also some technical dives, things with rebreathers and stuff. I'm also interested in history of diving, so that is why we are driving a museum here in Stockholm. That is a museum of diving, the diving tank house. And you're all most welcome to visit it if you have the opportunity. I have a background in the Navy for many years with mine clearance diving, standard, hard hat, saturation diving, experimental diving, and so forth.
Thank you.
I'm Terry Fisher. I've worked for AP Valves and ambient pressure diving since 1985. I'm involved in the development and production and testing of the inspiration and evolution rebreathers. Inspiration and evolution, whichever you want, and still involved in testing there. I dive for my work and enjoy it. So.
I'm David Dulett. I presently work for the US Navy. I'm also a cave diver. I'm a relatively inexperienced rebreather diver. I do dive the RB80 semi-closed rebreather when the circumstances call for it. In the Navy, as a sideline, I've been doing the manned certification testing of rebreathers when we're looking at new rigs.
Simon Mitchell from Auckland. I'm an anesthesiologist and a diving physician. My interest in diving is deep wrecks and photography. I dive an APD Evolution, a Sentinel, and a Mark 15.5 rebreather.
I'm Jill Heinerth, and I've been diving CCRs since, I guess, 1996, 97, and teaching them since the late 90s. Though I only just got my first rebreather certification myself last year, I think.
It was good. Richard, me, I represent Global Underwater Explorers. I head of a committee within the Training Council investigating the use of CCR technologies within our organization. As you might know, we have been resistant to use not rebreathers, we love rebreathers, but the CCR technology, but we are investigating any use of those systems for the future. There are lots of them during the last couple of years, RB80 obviously, but also lots of different brands, including Sentinels, Megalodons, and JJ CCRs, and so on.
Hello, my name is Arne Sieber. I'm an engineer, and my research is focusing on diving physiology and diving technology. For what concerns rebreathers, I'm mainly interested in small units for recreational purposes, as small as possible, as automated as possible, with good sensor technology.
I'm Dimitri Gorski, and I have a very simple mechanical CCR here in the Baltic Sea and in the mines and some other places in the world. One other in the Tuna Hasbury project I heard about yesterday.
Okay, thank you very much. So, to start it all off, I want you to ponder the question about rebreathers. I mean, it started with some plastic bags and tubing and pure oxygen, and we've come quite far since that. So, where are we heading? What do you think? How will the rebreathers develop in the near future? Anybody wants to take that up? Yeah, Arne?
If we look at now at the situation that rebreathers become available for the recreational diving, I think the systems will go towards automatic systems, totally automated systems with a lot of electronic control, like you find today in a car, for example. You have a network of microcontrollers taking care of you. This is what I think.
When I started diving rebreathers, they broke every time we went diving, so we never ever expected to come home with a working unit, and I think that created perhaps a different kind of rebreather diver than today. I'm diving a Sentinel today, and things just don't fail very often. So I think today we're at a very critical paradigm shift in the industry. We have a large marketplace now of consumers that can demand better technology and new features that they want to see, but I also think we're at a critical paradigm in the social and cultural behaviors surrounding rebreathers, and something that is the greatest challenge for us these days is to promote and police our own behaviors about how we use these technologies to make a safer, more productive market in the future.
Well, I just want to give the perspective of if we look back in time and look on the first halcyon unit, the fridge with Big Hal. It was a fairly complicated machine if you compare it to the RB80, and to some extent I think that we can see more or less the same push from electronics going into manual CCRs. So there is some kind of, I think innovation is very often an unexpected simplification of things rather. Innovation is always new, but I think it's often a simplification of things.
You disagree with Arne. Arne thinks it's going to be more automated, and you think it's going to be more manual. Is that how I should interpret it?
Well, to me, it's more or less what's been.
Yeah.
The way that innovation has gone.
Okay.
So far.
We have two guys that actually produce rebreathers. What do you say?
Okay, I'll start telling something. I will just spin back to what said here about the technology. I also believe that if you look at least 30 years ahead in time, there will be, of course, the electronic units that are completely automatic and it's really reliable, the sensor technology is there and it functions and so forth. But still, as the likeness here, you walk into your car with a fantastic engine, everything is running very smoothly, and you sit on a wooden bench. I mean, there must be much more in the design of the breathing set. We talk about loops, hoses, interaction and function with it, balanced breathing, etc. The flow through hoses. I mean, swimmers and they have the shark skin suits because you can get a few seconds shorter time in the water. We have to get the flows up in hoses by some type of technology. Bends, if you look at the rebreathers out there's a lot of 90-degree bends. All of this adds to the breathing resistance in the set. So you have to design also the breather, not only concentrate on how to exchange the oxygen that has been consumed.
I think basically technology will always get better, rebreathers will always get better, we're always trying to make them better. I think the major thing that's happening at the moment is most rebreathers out there, usual rebreathers, want to know how they work, and interested how they work, so they know, they look into it. We're looking at a recreational market now that's starting off with paddy, and they're trying to go down another route where it's for recreational divers who don't know how the unit works, to try and make it simple for them. I think that's going to be a challenge. I think hopefully people will get into that recreational side of it, try rebreathers and want to get more involved in rebreathers and know how they work. But I still think, as a manufacturer, people should know how it works. I know that the car thing, you've got nice cars that are very reliable, so you don't expect them to go wrong. Rebreathers, you're in a hostile environment underwater, and I think you've got to have some understanding how rebreathers work. So the new recreational side of it, I think, is going to be challenging for us.
Richard. I'm not an engineer, as you know, but my main profession is educating divers and so on. So I see quite big challenges in the future because there's two major paths. One being more automated, more advanced electronics and so on, and as it is more complex systems. To keep diver training up to specs, up to speed is going to be a major challenge with those units. And then we have, on the other hand, more straightforward systems, obviously not as advanced and so on, but maybe easier to train on and so on. And that's a challenge that's for all of us who educate divers. That's something that's going to come in the future also. So machine is one thing, but humans are also one thing, and it's the combination that's interesting, I think. Yeah.
What do you say about, I mean, most of us might think about closed-circuit rebreathers here, but we have semi-closed too. And some organizations prefer them, and some divers prefer that. Where do you see anything happening there? You have something to say there first. Go ahead. Sorry. And then we'll catch up later.
No, that's all right. We can move on. I was just going to comment on the future, and actually I was going to ask a question to a couple of the manufacturers here. This isn't entirely relevant to the technical diving audience, but I know a couple other communities in the military and the commercial are looking at taking rebreathers very deep, not fully self-contained, often not completely autonomous, but rebreathers nonetheless. So into the depths, 200 meters and more. Do you think that will ever come?
I think people are taking to those depths now. Yeah. Well, when you design a rebreather, we design rebreathers at the moment to 150 metres because we're limited at the tests we can do and the equipment we can test with. So I think the deeper you go, you've got the scenarios where you've got to bail out and you've got to be able to get out of those situations. So I think rebreathers can go to whatever the depth you want. Whether it's sensible to go there or whether you should be going there is a totally different thing. But you know, the technology is there. People push the limits. That is another problem with rebreathers. They perceive that, all right, we used to go to 100 metres, we'll go to 150 metres now, and that's the big problem with the industry. Well, divers as such, trying to push the limits too far past what rebreathers have been tested. I mean, people have took our rebreathers to over 200 metres. We've only tested 150 metres, so it's difficult to control that really. But they're capable of doing the depths that the militaries need. So, yeah.
Okay, quick comment on the depth there. What actually happened is that the oil industry was driving the deep diving in the late 60s and early 70s, and what they were doing that was bounce diving, very, very quickly down to very, very deep depths, very quick jobs because they had limited time and up again, and they have enormous amount of problems, and they killed a lot of divers. Then they turned into saturation diving, and suddenly the increase of the dive depths decreased a little bit, and they still had some accidents, of course, but they regretted that. And the other comment is that basically on the North Sea sector, almost all saturation divers are done with a rebreather as a bailout set on the back of the diver, giving him about a couple of minutes at maximum depth to breathe. Now they're trying to turn it all around, that you actually are breathing on the rebreather and then using supply hose as a bailout option. And that's mainly driven by cost of helium. So they can reduce the cost of helium by using a rebreather. They also get the warm gas and get other measures of that. And that is driven by Technip together with Statoil.
You wanted to say something there as well, yeah?
Just have a quick reflection on the simple versus automated systems that we were discussing before. And as an engineer working for the industry, I know that it's very difficult to develop those automated systems, and they need a lot of maintenance and they break down. And some people compare a manual rebreather to an electronic rebreather and say an electronic rebreather is automated and they're both safer. But since you need a lot of resources, we haven't been really able to do that before we had this massive amount of divers starting diving rebreathers. So it's only in the latest years that we have this boom in rebreathers. I mean, in the last maybe 2 or 3 or 4 years, nearly all my friends started to dive rebreathers. So I think we will have more and more developments in the years to come. And I think we're seeing it in this conference also with all the sensor technology, the new machines coming out. It takes a lot of effort, it takes teams of engineers, teams of scientists to accomplish this.
You had a comment there, Arne?
I think you're completely right with this, especially when you look now, before that, the diving market is not that big, there's not so much money. But if now the recreational industry starts to use rebreathers, then suddenly this is a completely different number of rebreathers. And there we go, there is more money for development, and I think this will be also for the technical divers a step forward, quite a big step.
The number one question that I get on rebreatherpro.com is, what rebreather should I buy? And my answer is always, it depends. Electronic, manual, passive, active, simple, complex, whatever. It's a tool ultimately, and our best guess on the closest thing to research that we can pull together based on the number of units sold and the accidents that we see every year, some 18 or 20 fatalities a year, is that there is no box of death. So it's how people are using these pieces of equipment and whether the equipment is suited for the type of diving they do. So if I was, encouraging a recreational diver these days, I might be thinking towards an intelligent semi-closed circuit rebreather, and yet a highly experienced technical diver may do better with a fully closed electronic CCR that can deliver a tool that's good for a variety of depths and times and everything else. So I think it's very hard to lump these all into one category. That we really do have to think of these as very specific tools with very specific behaviors and training requirements for each.
Okay, thank you. I think we should go over to the audience here now. Give you, I know you are a lot of people out here that have lots of experience, but maybe also many questions. So do we have any questions in the audience? We have one here.
Well, I have a lot of questions.
One.
Yes. So first, we have had in the industry a problem with availability for oxygen cells. And the question is, it has caused some issues for divers to get those. And what is the industry doing to prevent that? And this is not a question to Arne, this is a question more to you. I don't got your name. Yeah.
It caused divers a lot of problems. It caused us many, many problems. We were using a cell which was, as Arne said earlier on, we abused cells in the diving equipment. We used the Teledyne cell for many years. We developed the Teledyne cell with him to get it right, thinking this is the best cell for the job. When Teledyne decided not to sell cells to the diving industry a year last August, it was a big shock for us as well as divers. We tested all of the cells that we could on the market that we could find in our unit to get them through the EN 14143 testing. None of the ones out there could do that, so we've designed and developed our own cell, and hopefully in the future we won't have a problem with supply, because it's our cell, it's for us, it's for our rebreather, and as far as I know, you shouldn't have any problems in the future.
Thank you.
One other question, also there.
Okay, but in the future only one at a time, okay?
Well, also, when we're talking about the technology that Arne is bringing in front, how far are you Well, now I'm asking you the question as a representative of the industry of electronic rebreathers. How far are you from getting there?
Well, the cells we're developing, I mean, Arnie was on about the faces of the cells to stop the moisture going in. He says that the industry weren't looking at things like that because the diving industry is a very small industry for cells, but we're looking at that at the moment, and we think we've got the right seals for the faces for the cells for that. As for future improvements, I was quite interested in Arnie's talk as well on the CO2 sensors. But oxygen sensors, there are other ways we're going. There are things we're looking at, and as a company, we will always be trying to improve the oxygen cell we've got now. So these things are in the future, but when you're testing cells, as you realise, it took us over 12 months to get the cell on the market, because it's not an exact science. You can't design something, say this works, do 5 tests and send it out to the divers. You've got to age that cell, as Arnie said, the cells age with use and with humidity, with depth, with pressure. And so the development of cells takes a long time, but we're carrying on that development now. With cells around the market, they're going to get better. So hopefully your problem with cells for our rebreather anyway shouldn't be a problem. When testing and designing the cell, we found that, as you can see, some of the cells that are out there that other manufacturers are using didn't work in our rebreather. So not all cells, you can't make one cell and say that will work in every rebreather. Ours is designed specifically for our rebreather. It may work in another one, but the testing involved to say yes, use it in another rebreather, we as a company can't afford that unless somebody wants to pay us to do that. So it's very much, we're looking at our product and trying to get our customers happy, but we're not, I don't want to get the responsibility of the whole industry. It's just too much money.
Thank you, Terry. Yeah. Sure.
Can I ask you a question to that? In December 2010, there was a recast of the RHOS directive. Do you know this is this directive about hazardous materials, which basically said in medical consumables like oxygen sensors, you are not allowed to use any more materials like lead, which actually means that the current sensors that you are developing might. So what are you trying to do there?
Stand up and tell it. No, we have got ideas for the future, so we won't have lead in cells. There are ideas that are on the drawing board and we're looking at, but I'd rather not say them.
So, next question from the audience. Do we have any more questions from the audience? Yeah, let's take your audience first. No? Okay, sure.
Lars, as I understand, in the military industry, the rebreathers have kind of changed over the last few years. The interest for mechanical units has been increased due to some nasty accidents. I would like to ask you a little bit about that. Is that right, or is just what I'm getting as a hunch?
Okay, there is quite a few navies out there that actually use closed circuit technology, and they've been doing that for many years. What can be had is that some nations have acquired equipment that they cannot handle. I don't think the equipment is malfunctioning or it's bad equipment. It's basically you have to have the infrastructure and education, knowledge. Keep the timers up. You have to use it set a lot of times each year. And if you haven't supplied that, you maybe dive a couple of times a year. How can you have a complicated closed circuit set up in your mind? You have to make maybe hundreds of dives to be really proficient on it. And that's the problem. If the navies could afford to have all this training time put on the divers, that's no problem. But they don't. They want to shorten times. They want to shorten certification. They want to get out of the water quick, and they want to have less divers and so forth, cutting down. So that's the problem, basically.
I just want to add to that if you look at most Navy diving, it's not really that deep, and it's not really the necessity to use a closed-circuit rebreather is not very high. So most Navy diving is done with open-circuit scuba on air, and if you look at clearance divers, it's more of an operational thing to reduce sound and other effects that drive the need for a rebreather. So I think that in terms of navies, if they're going to use closed-circuit rebreathers, it's more often on kind of smaller units designed for specific purposes, deep diving or so on. So I think it's a fairly small number.
Richard he was first, I think.
I actually have a question.
Okay, then I misunderstood.
And two questions. We have ambient pressure here, so one question for you guys. All of us have a perception that the market has grown over the years. Obviously it has, but how big is the rebreather market? Not exact numbers, but how big is it? And for Interspiro, given the fact that market may or may not have grown recently and so on, are you pitching your new products towards not only Navy, or are you looking into the recreational side of equipment sales and so on?
Right. The rebreather market is a very big market. There is not just our rebreathers on the market now, there are a lot more. And the more rebreathers on the market, the bigger it will get. I think this next 12 months or so, when the paddy recreational starts, it's going to be a big influx into the market. It's going to be interesting to see how it goes. But yeah, it's a very big market now. When we started in 1997, we knew from our research that we could probably sell 300 rebreathers. We weren't sure how many more we could sell, but we made the investment in that, and it has proved very successful. And hopefully it will carry on.
So you actually have sold more than 300 rebreathers. Okay. From my side perspective, I mean, Interspiro is only currently making pure mechanical sets, and we also only aim at professional military divers, so we don't sell to currently to the civilian sports diving market. However, if we did that, we would have what Richard is asking for, a set that you virtually can put on your back without any education and dive. But coming back to that. Yeah.
Okay, thank you.
I would like to talk a little bit about training, because now we've been talking a lot about technology, almost a lot about technology. And I also want to ask a question to all of you, actually, because you've been around for a long time. When you go now with a rebreather somewhere in the world, to a boat or something to dive, they often don't know what to do with you. They're kind of a rogue element. You're not supposed to be in a team. You can dive by your own. And normally even don't give you any time. You just come back sometime. Maybe they don't expect you to come back. I don't know. It's not like that, but it's almost. And well, the thing is that I was thinking that maybe in the 90s, when technical diving became really big, we had this boom in technical diving. Is that something that happens now in rebreather diving? And we saw these developments in training since the 90s in technical diving, OC diving. Is this something that you think is going to happen now in rebreather diving? We're going to have a lot of development in training as well, in the way we teach rebreathers and things like that. Or is it going to be just the same way we do it now?
What do you say, Jim?
Yeah, again, there's so many challenges with so many new rebreathers on the market and a growing consumer base. There's a demand for a lot of instructors and not a lot of experience base out there. So it is a very challenging time to keep the industry safe. And yet we're also challenged by having a consumer market with no education buying a unit, perhaps based on the comfort of the harness or one pool session. The color, yeah, exactly. And so there's an education needed for the instructor level, there's education needed for the consumer before they purchase a unit as well. And yeah, I think that presents a lot of challenges for training. at Rebreather 3.0 in May, which I hope many of you will try and attend in the United States, because we only have this about once every 15 or 16 years. I hope that we'll develop some strong community-wide standards. I'll be running the session on training, and hope that we can come to some agreements about things like instructor currency and whether an instructor should be teaching on many different units or should be only teaching on the one they're proficient on, and what kind of industry-wide support do we have for the background of a particular instructor before they begin training, and those training-based dives versus experiential dives. So it's a very challenging time in the market, and I hope that it grows and develops as much as the training in technical diving has in the last decade.
Can't agree more. And a particular problem that we foresee as an organization that are investigating if we're gonna do this or not in the future is the fact that as we look at it, we need to cooperate strongly with the manufacturer to be able to train on a unit to start with. If we don't have that strong connection with that manufacturer, we will lose out information. These are some of the systems are highly complex, the electronics with updates, software updates, firmwares. Most of us struggle to keep our PCs running, right? So we need to have that cooperation with manufacturers, and that's of course problematic as it is, but that's also a challenge for the future.
Terry, how do you see on this question with education from the manufacturer's perspective?
Well, we get involved with all the training agencies on our rebreather. They've all got generic rebreather courses, but then we put into their courses what we think should be done on ours. But Martin Parker will be at the event in Florida, and I think that's going to be a good thing because everybody's getting together and talking about the industry and training, and so we are trying to do that. And I say, education on rebreathers, it frightens me sometimes when I hear people say that got a rebreather that you can put somebody on with almost no education. Because to me, having sold rebreathers now since 1997, education is everything. You've really got to know what you're doing before you go on those rebreathers. Because we're in a hostile environment on a machine that's keeping you alive. If you are willing to get in without knowing how it's working, it's sort of taking it out of our hands, really. People really need to educate themselves through the industries on the rebreathers they can use them.
Thank you. No, I'm not angry about that, but I'm not suggesting that we sell a rebreather without education. Of course, we have to educate our customer. That is natural. And what I'm more or less upset is that usually you encounter some divers that they think they know everything, and they won't participate because they just want to have the set, so to say, and start diving. But even an old fox as a diver will pick up a few pieces here and there that can be useful, and that is what I think is important when you have equipment. You have to tell the customer how to utilize the equipment, how to get full function of it and maximum performance. And they might know everything about the technology behind it, but still there can be some important facts that we have to educate them on. And I'm coming back to that. Our mechanical set, which is out there, you can please come and look at it. It's very, very simplified because it's been actually constructed in a way so it does basically everything for the diver. So it is very easy actually. You can put it on the back and go diving without a lot of education anyway.
I have another general question, and if you have any questions here, just hands up, and meanwhile I'll go on here. If we can, pretend that we are omnipotent and see in the future, how would we like rebreathers to be? Where would we want the technology to go? If we don't limit ourselves to what is possible right now, but as users and manufacturers, how would you like it to be?
Well, I have a comment from the military point of view. Really, rather than a user, but interacting with the military users is although you say you need a lot of training, and the military or at least gets a lot of training on their rebreathers, they also, if you're diffusing a mine, your mind's elsewhere rather than on your PO2. So I know as the military users, they really want something that works without a lot of interaction. They know how to dive them, they can dive them when the electronics fail, and they know how to do that, but they're not always able to do that. And as technical divers, there's situations where that may be the case as well. So I mean, that's something from a military point of view. And when we do hand certification testing, we test them completely hands-off, you know, just to see how they'll behave without the diver making the normal interaction with the rebreather. So that's something we like to do.
That's also a very interesting thing you said there, because you can test a rebreather and find out how it works and if it works well or not or whatever. But there is also the complete picture. I mean, you have to transport the breather out to the dive site. You have to put it on, you have to dive it, you have to be comfortable to dive, you have to be easy to ditch, you have to be able to rescue the diver and do a lot of other things that you do not measure by pure oxygen exchange functions in it. It's much more ergonomics into it, how it operates, how easy it is to dismount and clean and service and so forth. So there's a lot of other factors that are very important also, especially from a military point of view.
Jill, how do you see the future, or want it to be?
There are far better technology people on the stage than me, so I'll give you my view of nirvana, and that's that every diver uses a checklist and thinks they're cool. That they force their dive buddies to use checklists because they're cool. That everybody does a 5-minute pre-breathe with their nose blocked, seated in a comfortable position where they're monitoring their rebreather, and that they don't get in the water with one small failure, like a sensor that's out or a manual ad valve that's sticky, that they abort the dive when they fail the pre-dive check or fail the pre-breathe. Because I think if we have those behaviors, we're going to have a whole lot less accidents and incidents. It's just those simple rules that'll save your life. And so I hope that that becomes the cool culture in the future.
What we are looking for is mainly an exploration tool, actually. That's why we started as an organization to look into these things. We want something that we can, like in the projects we've done in China recently, where logistics with equipment has been a major problems. We have carried stuff, we have had long transportations. We can't really, our units cannot be treated nicely on those expeditions, and we want them to be able to work. It's not fun to spend 2-3 days to carry up equipment, and then you put it together and then it's no show because the sensor doesn't work or whatever. We want something to be realistic but simple. If I can't explain to myself or my students how this machine works, how on earth can I expect to teach somebody to use it, or even worse, dive on it if I don't understand how it works. I want something that's simple and reliable. And the Achilles heel for us has always been the sensors, so it's been great to look at the presentations and explanations from you guys. Yes.
I completely agree with you, and also have another user perspective. I'd like to see a rebreather which I don't want to modify as soon as I get my hands on it.
Anybody else that dares to wish?
Well, from a purely technical point of view, usually people I tend to want to have rechargeable scrubbers so that they don't need to change solar line. There's been some research in the area, mainly solid amines, which you then heat up and the carbon dioxide is evaporating from the substance. The problems mainly is verifying that you actually have recharged your CO2 absorbent so that you actually do have a full lifespan again. I actually myself made an innovation back in 2000, that's why I was employed for diving research, and that was a similar design but for the oxygen, where basically you have an oxygen absorber, blow air through it, so the oxygen is absorbed, and then with moderate heating, the oxygen is then released into the loop while you dive, and then you surface and recharge the system again by just blowing air through it. So the future is hopefully something like that.
Automatic scrubbers and oxygen producers, something like that.
Yeah.
You go ahead, then we have also a question from the audience afterwards.
We talk about technology, sensors and so forth. I mean, virtually, if you had unlimited amounts of energy in a very, very small package, you could extract oxygen from the water that you're diving in and have a rebreather that could last you basically forever.
A bond breather. Now that sounds good. Yeah. We have a question here?
Yes, I have a question. I'm a doctor and I work with divers and so forth. These new technologies drives the diving into the screens. So it's a very high upload when you get injured during dive. Sometimes you have to abort the dive and miss the decompression. Does these new technologies give new demands for treatment? What are your concerns? Or should the divers also perhaps start treating themselves better in the field, in water recompression, things like that?
Anybody wants to pick that one up?
Yeah, so there's a couple of questions there. Do the sort of injuries we see from the accidents that occur with missed decompression mandate different types of treatments that we would use for someone after an air dive who presents with some joint pain? And the answer is that there's no evidence that any form of recompression other than a US Navy Table 6 with or without extensions is better than that baseline treatment. There are some suspicions that certain strategies might be, but we have no data to show that. So if you ran a hyperbaric chamber and a very sick technical diver came in and you did a US Navy Table 6 with or without extensions as indicated by the diver's condition, I don't believe that you could be criticised by anybody. There are some people, if they had the capability for deeper recompressions using helium and a table like a Comex 30 or some variant on that, they would do that, but there's no data that says that it's any better. And the other point I would make about these sick technical divers is that what we, and I don't sick as in decompression sickness, is that the thing that's often overlooked, and I see this reasonably frequently, is that everyone focuses on recompression as the most important, the paramount consideration when you've got a critically ill diver. It's actually not the paramount consideration. It's important, but what those divers need is proper intensive care at a properly equipped facility with doctors with the right kind of expertise to support a very sick person. If you take a diver with fulminant cardiopulmonary spinal decompression sickness to some peripheral chamber that's run, no disrespect to general practitioners, but run by a general practitioner who can't manage an airway, can't, provide intensive care level treatment, the chances are that that patient will do badly no matter what happens to them in the recompression chamber. So often the need for intensive care level supportive treatment is overlooked in these very sick cases. The second question is around whether divers should recompress themselves, and that's a real can of worms. So I think the medical profession is quite conservative on this, and many diving physicians believe divers should not do it. I'm not of that view. I think that properly equipped, trained groups and focused groups of technical divers probably do have the wherewithal to provide in-water recompression therapy, and I think that the advantages are potentially large. I think that the window of opportunity to ensure a good outcome in serious, rapidly developing decompression sickness is short. It's probably measured in minutes rather than hours. And an evacuation to a chamber almost always involves hours, not minutes. And so there's quite a compelling argument for in-water recompression, but not by people who don't know what they're doing. So groups of technical divers with full face masks or mouthpiece restraining devices, a source of 100% oxygen, a properly set up recompression stage with the support divers that can accompany a person who is capable of getting back in the water, where the thermal considerations are not insurmountable, etc., etc. I would think it's a reasonable thing to do, and some of the technical diving training agencies are moving in the direction of designing in-water recompression courses. It's not a simple matter though, and there'll be a lot of controversy over it, but in principle I agree with it in properly selected cases by the right people.
Thank you. We have another question over here.
Yeah, just one short question. A couple of years back, rebreather diving would be considered a risky diving business. But the development in the last couple of years within technology and education, can we say that rebreather diving today is much less risky and has reached a level where it's not more risky than open circuit diving, or would you still consider rebreather diving to be a little bit more risky business than normal diving?
You two over here?
Unfortunately, I don't think we're in a position to say that. So the data is very soft. It's very soft. There's about 20 fatalities a year, and it's been that way for about 5 or 6 years now. And so how that compares to other forms of diving depends entirely on your denominator. So how many rebreather divers are out there and how many dives are they doing? However, what we know from DAN research is that the fatality rate per participant for open circuit scuba diving, so normal recreational diving, is about 16 fatalities per 100,000 divers per year. That's hard data, that's good data. We have 20 rebreather fatalities a year. If there are 10,000 rebreather divers out there, that's about 160 deaths per 100,000 divers per year. So that's about 10 times the rate for open circuit scuba. If there's 5,000 rebreather divers, then it's twice that rate, and if there's 15,000 rebreather divers, then it's half that rate. And that's the level of precision we're at. We really do not know how many rebreather divers there are out there. But I would say, whichever way you cut it and look at the data, at this present point in time, rebreather diving looks like it's about 10 times, at least an order of magnitude more dangerous than standard open circuit diving. That's a broad brush statistic across the entire range of rebreather diving. I mean, obviously there's lots of variability in what people do with rebreathers, how often they dive them, and different people's risk will be different, but that's the broad brush statistic, and that's kind of where we are at the moment. I wish it were different, and let me tell you, I cannot endorse the comments made by Jill and Richard more strongly. Training is everything, culture is everything. Jill's nirvana culture shift where everyone thinks checklists are cool and nobody gets in the water with a malfunctioning unit, and that is so true. It is the most important thing. It's humans that fail in these things, it's not the machines. Almost all the accidents, and I'm involved in looking at a lot of them, are pilot error. We're never going to, and I know there are some good friends of mine. Kevin Gurr believes you can engineer this out. He's a good friend of mine, but I disagree with him. Alex Diaz believes you can engineer this out. He's not a good friend of mine. I disagree with him. It's the humans that make these errors, and we need to change our training and our culture. We need to optimise our training and change our culture.
We have one last question over here, and then I think we have to... Oh, we have another one there. Okay, 2 questions, and then we'll have to break. Start here.
Okay, my question is related to education again. To me, it seems like rebreather training is very based on technology and not general education. Is there or even personalized training, actually? It's not standardized, and it's not you don't have a curriculum that's about general rebreather diving. It's mostly based on the machines you dive. What is your take on that?
Who wants to pick that one up?
Well, it kind of has to be linked into the machine that you train the people on, right? Well, you can train the basic skills as a rebreather diver and so on, but since the machines work differently and so on, we have to train according to the manufacturer's suggestions and so on, and that's very important. The number one class request for GOE these days is to do our fundamentals class that teach you good diving skills and so on, but on a rebreather. And well, that's an encouraging note, right? But how on earth could our instructors accommodate 4 students with 4 different rebreathers working in 4 different ways? And the common question is for our instructor corps, as we have them today, since they don't have the rebreather experience. A funny question came from one of our instructors. We can't even tell if they're living or dead because they're not blowing bubbles. Okay, understand what's going on here, right? So it's important that it's keyed into the equipment too.
Well, actually, of course it is a problem, but in current CCR cave classes, they often have students having different units. And the CCR cave instructors manage that basically by just leaving the rebreather handling to the students, and they have to know that to come to the class, and then they teach them the actual cave diving with the rebreather. So could be the way. You should teach them the fundamentals of diving with the rebreather, like the swimming techniques and the balance, and that is the same for any unit. You just move weights around and teach them how to swim with things like that, and just
a quick comment. Yeah, the problem is the liability thing there. If the instructor doesn't understand the system that he allows the student to jump into the water with, it's a problem as it is.
When we started teaching rebreathers, we did teach them quite generally with sort of Mod 1 kind of standards, and then we got a lot more specific unit by unit, and I think we're now hitting another evolution where with Patty's new programs, again, they're quite generic at first, so that everybody's going to have the same basic modular lessons with the instructor's addition of the type-specific materials. So it's kind of a nice balance I think they're coming to, and I'm quite excited to see how this works out with them.
I mean, if it comes to my vision, I think in general it's just a question of time till everything gets a little bit more standardized, and this also includes the units. That also then it's much easier to switch from one unit to another. So this is what I think. It will come and it will become easier.
Don't we have the same problem or a similar problem with dive computers? Wouldn't that be, if we just think about dive computers and the difference between dive computers, and they are getting more and more complex, and should we have diving courses for each dive computer? I don't know, or standardized dive computers so everyone looks the same?
As far as I know, there is a course for diving computers from Paddy, with one specific model.
Yeah, I can see your point there a bit, but it's not the dive computer will not decide. It will not put gas into your mouth in different proportions and so on. So it's a difference, honestly. And for us, GOE, it's simple. We use bottom gauges and not so much dive computers. But it's not really the same thing.
Okay. The last question in the back there.
Yes,
no?
I just want to tell that I fully agree with everything that was said about the need for intensive care, recompression, and also the possibility to have an open possibility for an in-water recompression under certain circumstances. But I would like in this community here also to point out the fact that the need for pure oxygen breathing immediately when you feel something, and also rehydration and to keep the victim warm. These 3 simple measures you can take on the dive site long before you think of any possible contact or transport or anything. Immediately 100% oxygen, rehydrate and keep the victim warm. Then you can arrange for contact with the diving doctor, transport, recompression, intensive care, and whatever is needed. By the early oxygen, you can stop a lot of the events that comes with the decompression illness. And I also would like here to mention that I have questions every now and then from tech divers and very devoted nitrox divers that I've been on maximum oxygen exposure. Do I dare to take oxygen after the dive? And the answer is, of course, when we use oxygen after the dive, if you have symptoms that you believe are decompression illness or something similar, you use oxygen as a drug. And with drugs, we accept some side effects. So never ever hesitate. Use oxygen and use it a lot.
Okay. That was unfortunately the last question because we do have to continue. So thank you very much for your interesting views on this. Let's thank the panel.